Okay, let's do the next one, that is the third one. Okay, that is, let A, B, C be the sets such that A equal to A union B is equal to A union C and A intersection B is equal to A intersection C. Then show that B is equal to C. Okay, three sets A, B, C. Okay, and here they are given that A union B is equal to A union C and A intersection B is equal to A intersection C. So then we have to show that B is equal to C. Okay, that set B is equal to set C. Now you see, we have learned in our earlier exercises that if you take two sets, say for example A and B, okay, two sets A and B, then A is equal, if A is equal to B, then A is a subset of B and B is a subset of A. Okay, we have learned this earlier. Okay, also also if A is a subset of B and B is a subset of A, then A is equal to B. Okay, we have learned this earlier. Okay, two sets are subsets of each other if then they are equal also. Okay, and vice versa. If, see, in the same way here we have to show that B is equal to C, that set B is equal to set C. So we have to prove it. To show that these both are equal, we have to prove that these are the subsets of each other. Okay, in this, according to this method, this property of formula. Okay, so if you take B equal to C, if you want to show that B is equal to C, then we have to prove that B is a subset of C and C is a subset of B. Okay, now we'll do that. Okay, so let's take first B is a subset of C. Okay, let it be A. Okay, B is a subset of C. Now we'll prove that B is a subset of C using these conditions. Okay, these are the conditions given. Okay, now for B is a subset of C, let's assume as X is an element of B. Okay, let us take, let X be an element of set B. Okay, so if X is a element of set B, we can say this element X belongs to B. Okay, so we can write it as X belongs to B. Okay, so X is an element which belongs to B. Okay, if X belongs to B, then using this, if A union, then we can say that X also belongs to A union B. Okay, if you do the union between two sets, that is A and B, then X will belong in that union also. Okay, now since X belongs to B, if you take A union B, X will also belong in that union. Okay, so we can write this as X belongs to A union B. Okay, now see here they have given that A union B is equal to A union C. So instead of A union B, you can write A union C. Okay, so we can write X belongs to A union C. Okay, since given A union B equal to A union C. Okay, the reason, since these both are equal, we can write, instead of this, we can write A union C. Okay, now if X belongs to, this element belongs to A union C, then this element may belong to A or this element may belong to C. Okay, so you can write X belongs to A or X belongs to C. Okay, now you see we have taken X belongs to B, X as an element of B. Now we got it as X is an element of A or X is an element of C. See, we got X is an element of C. Okay, that means the element X of set B is also in set C. We can say that B is a subset of C. Okay, so we can say that B is a subset of C because the element X is also in an element of C. Okay, this is a case. Now in this here you got X belongs to A. Okay, X belongs to A, and here we have taken x belongs to b. That means x is common to both a and b. Okay, this element is in a and this element is in b also. Okay, this is common for both. So if it's common, we can say that x belongs to a intersection b. Intersection is nothing but the common between the of the two sets. Okay, since x is common for a and b, x belongs to a intersection b. That means we can write x belongs to a and x belongs to b. Okay, x belongs to a and x belongs to b. Okay, see, again we got x belongs to b, x belongs to b. Okay, see, before that, we'll do one more step. See, since x belongs to a intersection b, see, it's given that a intersection b is equal to a intersection c. Okay, so instead of this we can write a intersection c because these both are equal. Okay, so we can write x belongs to a intersection c because a intersection b and a intersection c are equal according to the condition given. Okay, so now we can say that x belongs to a and x belongs to c. Okay, because it's common for both, we can say it is also belongs to a and it also belongs to c, the element x. Okay, now see, we have taken x belongs to b and we got x belongs to c. That means the element x of b is also in the set c. Okay, so we can say b is a subset of c. Okay, so again here we got b is a subset of c. Okay, now see, we have proved that b is a subset of c. Okay, so this is our result. Okay, first result, b is a subset of c. We have proved here also, we have proved it here also. Okay, now this is over. Now let's prove that c is a subset of b. Okay, now let's take it as b. C is a subset of b. Okay, now let's take an element. Okay, again let x, okay, let's take y here. Okay, let y belongs to y be an element, sorry, let y be an element of set c. Okay, since it's an element of c, we can write y belongs to c. Okay, y belongs to c. Okay, now we can say that since y belongs to c, we can say that a union c, okay, y belongs to a union c also because it's a union with c. We can write y belongs to a union c because in this union c is there, so that element will also be present in a union c. Okay, now since it's given that a union c is equal to a union b, we can write y belongs to a union b. See, we have to bring this y belongs to c. We have to prove that c is a subset of b. Okay, so we have to bring that element to b. Okay, then only it will be proved. So y belongs to c, then y belongs to a union c, and y belongs to a union b because these both are equal. It's given a union b is equal to a union c. Okay, now since y belongs to a union b, we can write y belongs to a or y belongs to b. Okay, y may belong in this or in this. Okay, now again here we got two cases. Now see, we got y belongs to b, we have taken y belongs to c, and we got y belongs to b, which must be proved. Okay, now this element belongs to in c, also it belongs to b, so we can say c is a subset of b. C is a subset of b. This is what we have to prove. Okay, and here if you take, we have taken y belongs to c, and here we got y belongs to a, so this element is common to both these sets. Okay, that means we can write y belongs to a intersection c because it's a common, intersection is a common element. Okay, now this, see, now again here we have A intersection C is equal to A intersection B. So instead of this we can write A intersection B. Okay, so instead of this, y belongs to A intersection B. Okay, so now we can write y belongs to A and y belongs to B. Okay, so we got y belongs to B. Okay, here y belongs to C, we have taken, we got y also belongs to B. That means C is a subset of B. Okay, again we got C is a subset of B. Now we have got the result, we have proved that C is a subset of C. Okay, here also, so we got, this is our second result. Okay, this is both our second result, we have proved it. Now according to, so we got B is a subset of C, the first result, by 1 and 2. Okay, by 1 and 2, let there be statements. Okay, statements. Okay, statements or results. Okay, you can write results or anything. By first and second results, we know that B is a subset of C. Okay, we know that B is a subset of C and C is a subset of, we have proved that B is a subset of C and C is a subset of B, which implies B is equal to C. Okay, according to our earlier property, if this is a subset of this, it's both a subset of each other, then both those sets are equal. Okay, if these are subsets of each other, so we have got that. Okay, we have proved it. B is equal to C by showing that B is a subset of C and C is a subset of B. Okay, that's it.